We've already covered the power rule. So today is the product rule and the quotient rule. These are rules for finding derivatives. Based on a function that would be defined in terms of a FOIL problem. That's what a product is. All right, so product rule. If you have A times B and you want to prime that, in other words, you want to find the derivative of the product A times B. So the rule for that is B with the prime of A plus A with the prime of B. Now technically the order doesn't necessarily matter because we're adding and multiplying, but you want one derivative paired with one original function, and then you add the sum. So that is called the product rule. So it's two separate products added together, proved with Newton, proved with Leibniz, but that's the product rule. The quotient rule, if you have the fraction A over B, assuming that B does not equal 0, of course, because you can't have that. If you're trying to do a prime on that, and you want to find the derivative of that, that also starts with B A prime. But it's the subtraction then of A B prime. And what else does it have that the product rule doesn't have? It has a denominator, right? And the denominator is not a prime at all, but it is B squared. So those are the two rules your homework is going to focus on tonight. We'll do a sample of each, and then I'll let you loose on your homework. All right, so just important as a caveat to make sure with the quotient rule that you do specify the denominator is not equal to 0. All right, so one example of each. If we're trying to find x squared plus 1 and the product of that with x cubed minus 3x, so that's the product, and to that whole thing we would like to apply the prime. So that would be Newton's way of writing that, by surrounding the whole thing with parentheses and putting a prime. Leibniz, on the other hand, would surround the whole thing with parentheses, and he would preface it with a d dx in front. Either way, you're finding the derivative of this product. So I start with the b quantity, which is x cubed minus 3x. Multiply that by the prime, the derivative of the a quantity, using my power rule from previous. So the derivative of x squared plus 1, what's the derivative of x squared? 2x, and then plus 1 is 0, so I have my derivative. Plus, okay, now we want the a quantity, which was x squared plus 1, times the derivative of the b quantity, which the derivative of x cubed, according to the power rule, is 3x squared, and the derivative of negative 3x is negative 3. And so you end up with 4 parts of your product rule. You simplify and combine like terms. So by distributing, I have 2x to the 4th minus 6x squared. And then with the last term, I'm going to FOIL. And so I'll end up with 3x to the 4th minus 3x squared plus 3x squared minus 3. And so I just look through, now that I've simplified that, now I want to combine like terms. So I have 5x to the 4th altogether. For my x squared terms, I have minus 6x squared a minus 3x squared and a positive 3x squared, which leaves me with negative 6x squared, and then minus 3. All right, so that's the product rule. Any questions on that? Okay, then one example of the quotient rule, and then you have the rest of the class to work. Okay, if we have the quantity x squared minus 1 over x squared plus 1, and we want to find the derivative of that. I don't have to worry about the denominator because it won't ever be 0. This is not reducible either, although it's tempting. It's tempting to look at the x squared terms and want to distribute or want to reduce, or maybe look at and say, oh, it's a difference of squares, I can factor it, but that doesn't help me either. This really just is simply a quotient rule problem. So we start with the bottom quantity, which was x squared plus 1, and then the derivative of the top, which is just 2x, and then we subtract the reverse, x squared minus 1 times the derivative, which is also 2x. So you've got BA prime minus AB prime, all over the quantity x squared plus 1, that's squared, which will never be 0, because you can't make that even negative. And so we'll distribute and simplify, so we end up with 2x to the third plus 2x minus 2x to the third plus 2x, all over the denominator x squared plus 1 squared. So I have two like terms that will cancel each other out, the cubic terms. And when the cubic terms cancel each other out, I combine. My numerator becomes 4x, and my denominator is x squared plus 1 quantity squared. Again, denominator will not be equal to 0. Yeah? Yeah, you're going to need to FOIL it out and simplify. If we were working with square roots and stuff, maybe not, but these polynomials you should be able to.